Welcome back to the Physics guys, and in today's video we will discuss about one of the important derivation of class 12 physics chapter 2, potential due to the point charge. So let us start the session. The equation of potential due to point charge can be derived using easy simple 4 steps. Okay, and for that case let us consider the figure which is shown here. Here we want to find out the potential due to plus q charge located at here at point A, which is located at distance r from the charge. So basically we want to find out V of r at particular A. Now in the definition of the potential, it is said that the amount of work done to bring unit positive charge from infinity distance to the point will be given as a potential at that particular point. And for that case, consider the journey of 1 coulomb charge from infinity to point A via point P and P prime. Now position of P is at the distance x from the charge q, and position of P prime, which is very quite near to the point P, at the dx displacement. What is the first step? During the journey of 1 coulomb charge from infinity to point A, whenever the plus 1 coulomb charge reaches at point P, then the amount of Coulombian repulsive force experienced is shown by this arrow here. Okay, so the first step is to find the force between q charge and 1 coulomb charge at point P, which is located at the distance x. And you know that from the Coulombian force equation, F is equal to 1 by 4 pi epsilon 0 q into 1 by x square. So it will be 1 by 4 pi epsilon 0 q by x square. Tell this as equation number 1. And you can see that the direction of force is radially outward from the q. Now in the second step, what we have to do, let us move the 1 coulomb charge from point P to P prime with a small distance dx, small displacement dx. So let us find out the work done to move a plus 1 coulomb charge from P to P prime. Then that work done, small work done to displace dx is given by dw is equal to force multiplied with displacement. And since work is a scalar quantity, so the two vectors dot product will be expanded. Dw is equal to f dot dx into cos theta. dw is equal to f dot dx into cos 180. As you can see in the figure itself, the direction of force and direction of displacement are quite opposite to each other. So the angle between them will be 180 degree, and cos 180 degree we can say that it is equal to minus 1. So dw, small work done, is equal to minus f dot dx. So dw is equal to, putting the value of f from this equation number 1 by 4 pi epsilon 0 q by x square into dx. Tell this as a equation number 2. Now in the next step, what we have to do, once we got a small work done to move from P to P prime for a small displacement dx, we can apply the concept of integration to find out the total work done to move a unit charge from infinity distance to the point A. So next step is to find the work done to move 1 coulomb charge from x is equal to infinity to x is equal to r with the help of the integration of equation number 2. So integrating equation number of 2, we will get total work done. It is given by integration from x is equal to infinity to r dw is equal to x is equal to infinity to r. Putting the value of dw from here to here, it will get this equation. Now next step is that taking minus q by 4 pi epsilon 0 common, integration x is equal to infinity to r 1 by x square dx. So minus q by 4 pi epsilon 0, x is equal to infinity to x is equal to r, taking x square on the numerator, it will be x to power minus 2 into dx. Now use this integration formula, integration x to power n dot dx is equal to x to power n plus 1 upon n plus 1. If we apply this formula here, we will get minus q by 4 pi epsilon 0, and the integration will lead to x to power minus 1 upon minus 1 with the application of limits x is equal to infinity to x is equal to r. Now further simplifying, W is equal to minus Q by 4 pi epsilon 0, x to power minus 1 upon minus 1 will be equal to minus 1 upon x in infinity to r is equal to minus Q by 4 pi epsilon 0, putting the value of limits here. So first we will put value of r here, then minus, then we will put the value of infinity here. So it will be minus 1 by r minus into minus 1 by infinity. This simplification will lead to the 1 by 4 pi epsilon 0 Q by r. So tell this equation as equation number 3. Okay, so the next step is the use of the definition of potential, that potential is equal to work done. So potential at point A due to plus Q is equal to work done to bring plus 1 coulomb charge from infinity to point A, and here we know that the work done is already found with the equation number 3. So V of R at point A is equal to W. So V of R is equal to 1 by 4 pi epsilon 0 Q upon R. So the equation number 4 is the equation of potential due to point charge, positive point charge at point A. Now let us go through these important points of the equation number 4. Since plus charge is there, that means that if charge is positive, the value of potential at particular point A is positive. But if charge Q is negative, then value of the potential will be negative. So for minus Q charge, the same equation number 4 will be rewritten as a V of R is equal to minus 1 by 4 by epsilon 0 Q upon R. That means that in general, the equation 4 for the plus charge or minus charge together with the sign plus or minus can be written as a V of R is equal to plus or minus 1 by 4 pi epsilon 0 Q by R. Now second point is that for point charge, that potential is inversely proportional to the distance and electric field is inversely proportional to the square of the distance. So if we draw the graphs for positive charge and negative charge showing the variation of electric field and potential at the same time, same place, then the blue line will give you the value of electric field, whereas the black line will give you the value of the potential. For the negative charge, as you can see, the value of the potential electric field will be like this. Okay, now another important thing is that see these two graphs, they are showing you the variation of potential V with respect to 1 by R. Okay, if you will see, then for positive charge it is straight line in the first quadrant, whereas for the potential for the negative charge it will be again a straight line in the fourth quadrant. So this is all about the potential due to point charge. If you haven't liked the video, please like it. If you haven't subscribed the channel, then subscribe it. Share this video with your friend. And in this tough time, stay safe, stay home, wash your hands with sanitizer frequently, and don't go out if it is not necessary. Thank you. Let us meet in the next video.